In this video, we're going to look at a couple of questions from an AP curriculum module about parametrics, but it's a good preparation for the AP exam. We've been given the position of a particle, you see x of t and y of t, so we have position. So finding the magnitude of the velocity vector. Okay, so we should get the velocity vector. So velocity be the derivative, so it'd be 2t and 2t squared. Now when we say magnitude of velocity, talking length, this means speed. Okay, it could be asked either way, but this means speed. So the velocity at time 2, if I evaluate, I put my evaluation, I say at time 2, velocity is 4 and 8. So the magnitude of that vector, we just use Pythagorean theorem, 4 squared plus 8 squared. So 16 plus 84 is 80. Square root of 80. We could certainly simplify that to be 4 square roots of 5 if you wanted to. Okay? So that is the speed or magnitude of the velocity vector. Next, it says set up an integral expression to find the total distance. Well, remember, distance is, for us, this is an arc length. This is saying the length of the curve. Okay? So this is an integral from 0 to 4. And similar to two dimensions, it's still a square root, but we do the square root of dx dt squared plus the derivative of y, so dy dt squared, and that's it. Okay, so dx dt, dy dt. So really, dx dt and dy dt are components of velocity. And sometimes, maybe I'll make a note here, velocity is dx dt and dy dt, like that. Those are the components, so pretty easy to do. Next, find dy dx as a function of x. Well, of course, dy dx is just dy dt over dx dt. Well, dy dt was 2t squared. Dx dt was 2t. So this is just t. But it says to do it in terms of x. So let's go back up here. We're told that x is t squared minus 2. Well, why don't I use that and say, okay, so t squared is equal to x plus 2. So t is plus or minus square root of x plus 2. And that can be my derivative. Okay. Finally, find the time that the particle is on the y-axis. Well, if something is on the y-axis, that means that it's somewhere along here. And that means that the x-coordinate must be 0. So let's go up here and say that x is 0, so that means that t squared minus 2 is 0. So that means that t is either plus or minus the square root of 2. Well, if t is plus or minus the square root of 2, it asks us for the acceleration vector. Well, acceleration, let's get that vector. It would be 2 and 4t. So at that time, we'd have 2 and 4 square roots of 2, or 2 and negative 4 square roots of 2. So we have two acceleration vectors when the particle is on the y-axis. Now let's look at one other here. It says a particle moving along the curve has a position of x of t and y of t. dx dt is 1 plus sine t cubed. It says the derivative of dy dt is not given. So we don't know y or the derivative of y. For any time, the line tangent to the curve has a slope of t plus 3. Okay, so if I know we always have a slope of t plus 3, that means that dy dx is equal to t plus 3. So even though I don't know offhand, but I wasn't given what dy dt is equal to, I know that dy dt divided by dx dt, which I was given, is equal to t plus 3. Well, then I can do a little bit of algebra and figure out what dy dt is equal to. So now I have, because I've got the derivative, right? Position was x and y. Make sure you see that. Position was x and y. Now I've got dx dt and dy dt. So dx dt and dy dt, which is velocity. So if I want the acceleration, I need another derivative of each component. So I'm going to start with dx dt. The derivative would be 3t squared cosine of t cubed. And I would need some product rule here for the other piece. I would have first times derivative of the second plus second times derivative of the first, which is 1. Okay, so this is my acceleration piece, and then I would plug in 2, because it's asking for the acceleration vector at time 2. So I would have 3 times 2 squared, so I would have 12 times the cosine of 8. And then 2 plus 3, so I'd have 5 times 12, I'd have 60 cosine of 8 plus 1 plus the sine of 8. And I could certainly do some simplifying of that, but that's my acceleration vector. Don't be thrown if they don't give you everything explicitly. They'll always give you a way to solve for it. We didn't know what dy dt was, but we knew what dx dt was and dy dx. So we know 2 out of the 3 pieces we can solve for the other. And then it's a matter of knowing what you've got. Once you've got the derivatives, that means velocity. So to get acceleration, you just go another derivative down and then plug in 2.